everyone. Good morning. My name is Minji Ri. 大家好，早上好，我是日本字。And today I'm going to discuss the topic of considerations for designing and creating Vision OS apps. Nice to meet you guys. Give me a big applause for me, please. Before we start, let me quickly introduce myself. I'm currently a tech mentor at Apple Developer Academy at Posttech in Korea. Previously, I worked as an iOS developer at a Korean startup called Mixer, where I specialize in creating AR apps. Oh, and you can call me a studie too. And this photo from the Budapest last year with Korea traditional clothes. At Mixer, users could play with cute characters with AR. During my time there, I delved into technical aspects of spatial computing as iOS developer. I also participate as an official sponsor as a K illustration player and collaborated with district office on project to provide spatial computing educations to elementary school students. This allowed me to observe various user experience with spatial computing and led me to contemplate how I can provide a better user experience. My interest in spatial computing continued after I transitioned to the Apple Developer Academy. And I was thrilled when the Vision Pro was revealed last year. I watched videos, studied hard, and even made apps. But I couldn't sure if my app truly suited for Vision Pro because I hadn't tried it myself. Also, I want to experience things like AR hand tracking that couldn't be executed with the simulator. So I participated in the Apple Vision Pro Developer Labs, and I had the opportunity to test my ideas and Vision Pro features with a real device in August of last year. After trying Vision Pro at the Developer Lab, I was surprised to find that the idea I had for testing didn't make the best use of its features. After the lab experience, I kept learning that thinking about which app would be suitable for Vision OS and how to make the user experience better. This led me to several experiments. Eventually, in February of this year, I launched Vision OS app on my App Store. Today, I want to share some key insights I've gained from designing and creating my Vision OS apps. So, today's session will actually be about considering for designing and creating Vision OS based on my experience. Yeah. Delivering the best spatial computing user experience involves many factors. However, due to the time constraints, I had to select only a few. It was challenging because there are many important aspects to consider. Today, I will focus on these three aspects: fundamental, elementary, 3D model, spatial input. First, let me talk about the proper utilizations of fundamental elements of Apple spatial computing. The app I introduced earlier is the fire gauging app. People enjoy. Okay. People enjoy. Oh, louder. Woo! Thank you. People enjoy the sound of crackling logs as a white noise to concentrate on the work, and use the sight of burning logs to clear their minds. However, since it's not easy to start a real fire, many people rely on videos or products for this purpose. But with videos, users can only listen and watch. Some users express concerns about the safety or find it cumbersome to use such products. Actually, I'm one of them. Therefore, I developed the fire gauging app using Vision Pro to offer a unique spatial experience and user interaction that couldn't be achieved with videos, while also addressing safety and usability concerns commonly associated with physical products. Ultimately, I have two core objectives which influenced how I designed the app. By default, I've launched into the shared space where apps exist side by side. And apps appear as windows and volumes. A window is a familiar and traditional interface where users can open, fully resize, and move windows around. Additionally, it is possible to insert 3D content into these windows. However, when there's a background in the windows, it can be difficult to fully view the backside of the 3D content. Like this. This is where Volume comes into play. Volume is a new 3D window style and designed to play objects and provide experience within a limited space, enabling content to be viewed from all angles. Just like this. So people can view 3D content, 3D objects from every angle. If you want to enhance the immersion of your app, you can open full space. While both Windows and Volumes have designated areas for displaying content, with full space, user can place content anywhere. Therefore, user can not only place content anywhere, but also hide their surroundings, fully immersing themselves and creating associating new experiences. Comparing shared space and full space again. In shared space, multiple apps can coexist side by side. While in full space, the focus is solely on your app. Window, volume, and space are fundamental elements of spatial computing. And I considered which element to use to achieve my two objectives. For the first aspect, using the app as white noise for work or as a break, coexistence with other apps was necessary. In this respect, I thought it was more appropriate to use the shared space environment, where my app could coexist with others rather than full space where other apps disappear. And to allow users to view the fire from various angles in 3D, I found Volume more suitable than displaying 3D contents in a window. Thus, in shared space, users can still use other apps and enjoy my fire from various angles using Volume, either as white noise or for taking breaks to gaze at the fire. The second objective was zoning out while watching the fire. Because I wanted to provide an immersive experience of gazing at the fire, full space seems appropriate. However, there's an additional considerations of full space, and that's the style of immersion. There are mixed, progressive, and full style. Mixed style is an immersive style where you can use the app while seeing the real world through pass-through, as blending with real world. So you might wonder, how is it different from the shared space? What is the difference? In this video, you can see that various apps coexisted with the real world in shared space. But after entering space with the mixed immersion style, all apps disappeared except for mine. Full style covers the pass-through video with immersive content, allowing people to be completely immersed in the world you've created. And progressive style is in between mixed and full. People can adjust the level of immersion using the digital crown. But if people who don't have a Vision Pro, they can't use digital crown. So if you're using a progress style and need to adjust the immersion level in the simulator, you can use this method. The menu at the simulator, I/O, and set immersion level, like this. Among those immersion styles, I found full style where users can be completely immersed to be most suitable for my purpose. At this moment, you might be concerned about the safety of the full style, which completely covers the pass-through video. It's covered all over surroundings. In the first style, if you move more than 1.5 meters from the starting point, the immersive experience ends. So keep in mind that designing an app to let users explore content over a wide area while fully immersed isn't possible. Also, in an immersive environment, if someone comes nearby, you will see them. My first time using Vision Pro was in a crowded place, and that broke my immersion easily. So when designing your app, think about both your app's contents and the environment where users will use it. This helps us choose the light elements and immersion style. So ultimately, my app is designed to enjoy the fire in two modes. When you're immersed in your work and using the fire as white noise or for ventilation, you can use it like this. And if you want to fully immerse yourself and relax while gazing at fire, you can use immersive mode. And my app is still in its early stage, so I have still room for improvement. One feature I want to include is detecting the surroundings to place the fire on the desk or providing users with the virtual gloves in the immersive environment. These features would require ARKit. And ARKit is only available in full space. So keep in mind that too when planning your app. And if you're interested in learning more about ARKit, I recommended this video. It is very below. You can see that. The title is Meet ARKit for Spatial Computing. To enhance user-friendliness, I believe merging the controls for adjusting the fire's attributes instead of having them separate would make it more convenient for users to change the fire's properties and simplify the app's layout. Like this. I want to merge controls. So I wanted to use ornaments. In Vision OS, you can place controls and information related to a window outside the Window's border area called ornaments. This prevents crowding or obscuring the window's contents. For example, in the Photos app, the tab bar ornament is on the left side and the toolbar ornament is at the bottom. You can easily create these ornaments using Swift UI's toolbar and tab bar, and users can also create custom ornaments. I attempt to add an ornament to my buyer represented in volume. It's easy to add in code, but custom ornaments did not render in volume, but my buyer was drawing in volume. So, however, fortunately, it was possible to add an ornament as a toolbar, but there were limitations. Left is the window and right is the volume using the same code, but the popover doesn't appear in volume. And sheets and other elements also don't work in volume either. This is the Apple project's code. And this code also didn't use ornaments or toolbars in volume. Instead, it used a completely custom view. So it's worth knowing that adding ornaments with the diverse behaviors to volume requires more development effort. Let's summarize our discussion on fundamental elements. You need to choose the right one based on the user experience you want to provide, including how to use 3D content, how to utilize ornaments, coexistence with other apps, and employing ARKit. There are many more considerations, which you can explore these videos. Yeah. So this is the end of the first aspect. Next, I like to talk about 3D model. There are various ways to create 3D model. I need to create the buyer model for my app. I studied computer science and graphics and collaborated closely with modelers at an AR startup. So I have some relevant knowledge. However, I didn't know how to use modeling tools. So I chose Reality Composer Pro, a tool from Apple for making spatial apps, because it seems capable of creating fire, and I had prior experience with it. Reality Composer Pro offers basic shapes and simple 3D assets. And you can easily add various components to these entities, like audio, physics, particle emitter. There are also default presets for particle emitter. So you can easily make cloud, fireworks, rain, snow. And this is for sparks. And you can change and set materials using shader graph in Reality Composer Pro. This is the sample project from the Apple. It's also possible to give input values to materials, allowing interactions with your code to change the materials. By using these features of Reality Composer Pro, I was able to easily create fire and add a feature to change its color. Regardless of the tools used to create models, you can easily manage them in code through Model 3D and Reality View. With Model 3D, you can easily add 3D models to your app, just like this. You can easily add a 3D model to your app with just a line of code. This allows you to easily incorporate 3D models into scenes like window, volume, and space, and even add simple interactions. However, for more complex interactions, lighting and material changes, etc., it's better to use Reality View. With Reality View, you can adjust lighting like this. Did you see the difference from before? Additionally, using Reality View, you can attach UI components to the model like this. This is the UI components. For one of the app features, roasting marshmallows, I need the marshmallows to be movable, detect collisions between entities, and express material changes in roasting based on the duration. So I use Reality View instead of Model 3D. But if 3D content is a not core part of your app's experience and it's just to support your content, you can use Quick Look. And you can provide a preview with Quick Look like this. And you can also simple interaction with this Quick Look. Regarding 3D models, with Reality Composer Pro, you can create 3D content simply and make your model interact with code. And you can also choose the way to display 3D content depending on the role of 3D content in your app. For more learning on this, check out this video. Photo time. Okay. So this is the end of the second aspect. Next, let's discuss about inputs. I think one of the most amazing experience offered by Vision Pro is the natural spatial input through eyes and hands. The interaction felt incredibly natural without any sense, awkwardness, or alienation. It's crucial to maximize this amazing experience while ensuring it doesn't cause user discomfort. In Apple's spatial computing, eyes function like a mouse pointer, so giving feedback on where users are looking and ensuring they are focusing correctly is crucial. During my initial experience with Vision Pro at the developer lab, I felt uncomfortable using some apps because they lack feedback on my gaze, leading to uncertainty about my focus. This experience showed me how important the hover effect is. While system default controls have it, custom elements don't. Initially, my app didn't apply the hover effect to the fire or marshmallows, leading to confusion about what was selected, and even users couldn't be aware that they could interact with them. They don't have hover effect. In Swift UI, it's possible to apply hover effect to UI components. And similarly, this also can be added to 3D content entities. So following my gaze with the hover effect provides clear feedback, indicating what's interactive and in focus. Eye intention is sensitive information and privacy is Apple's priority. The hover effect occurs outside your app's process, providing only information about which element is focused. so you cannot access the exact eye data points. Regarding inputs through hands, like this, there are gestures that use both eyes and hands. And there are also direct inputs like this. And custom gestures can also be created using ARKit hand tracking. I wanted to test this feature at the Vision Pro Developer Lab because it's not available on simulators. I created a test lab where users could use hand tracking to grab a paint spray and paint. But holding a spray in midair felt unnatural and uncomfortable. It's weird. Using my hand and eye like this, my eyes and hands like this, dragging directly from my seated position felt more intuitive and comfortable than physically reaching out to the spray point. The WWDC videos have also advised considering the lack of tactile feedback in direct interactions and compensating for this missing sensory information with other feedback types. For instance, the keyboard uses hover effects and spatial audio effects effectively. When I scrolled, I had to repeat this gesture continuously while scrolling, and it led to hand fatigue. Even if your hands are at the rest while performing minimal gestures, fatigue can still occur. What if the direct interaction involves holding your hands in the air? It could lead to faster hand tiredness. So, when designing an app, it could be good to consider whether there are too many repetitive actions and whether direct input is essential to avoid hand fatigue. So, in summarizing spatial input, providing appropriate feedback like hover effects and spatial audio and designing apps mindful of hand fatigue is beneficial. In addition, regarding input through eye, hand, voice controllers, I recommended these videos. Okay. So far, I've shared consideration that I found while using Vision Pro, and I'm developing for Vision OS. As I mentioned at the beginning of the session, not only are these important, but there are also so many important things. Therefore, I like to conclude this session by quoting memorable sentence I encountered during my running journey. Here is the sentence. With many ways for how software can look, behave, and react to input on this platform, there is more responsibility on designers and developers to make sure this experience are comfortable and accessible. I believe this responsibility applies not to just to inputs, but to entire design and development. With the knowledge shared at this conference and through further learning, I encourage you to create spatial computing apps that offer the best user experience. I will continue to strive for this as well. For those who wish to continue the conversation and enhance user spatial computing experience, feel free to connect with me through this account.
Yeah, that concludes my presentation. Thank you.
谢谢。